Hello.
Hello.
Hi Diksha ji.
Good
Good
evening.
evening.
Hi, good evening.
So today we are going to continue with our friend functions, right? So and then we are going to look at bitwise operators and interesting facts about bitwise operators and a bit of size of operator once again, as we are going to use all of these concepts further in these functions, right? So after doing friend functions, we are going to
Okay.
continue with that. So let's get started. So we have the basics of a friend function. Let's just go through this once again. So a friend function is a special function in C++ which, in spite of not being member function of a class, has privilege to access private and protected data of a class. So you create a friend function inside a class and it will have access to the private and protected members of that class, but it won't be a member of that class. A friend function is a non-member function or ordinary function of a class which is declared as a friend using the keyword friend inside the class. By declaring a function as a friend, all the access permissions are given to the function. So the keyword friend is placed only in the function declaration of the friend function and not in the function definition. So when we are declaring the friend function like this, then only we place the keyword friend, right? And when giving the definition like this, we don't have to place the keyword friend over here. So a friend function can be declared in any section of the class. So you can declare it anywhere in the class, public, private, or protected. So here's the declaration of the friend function in C++. Here's the syntax. So you create your class, right, and you can create your friend function anywhere. So for example, we created like this on the first statement. We give the keyword friend. Then we have to normally, like we give to any other function, the return type. We have to give the return type of that function, right? Then we have to give the function name, right? And then we have to give all of the arguments. So everything is same, like we create a normal function declaration. This is a normal function declaration, just we are giving the friend keyword before, right, to create a friend function. So here's an example of using friend functions in C++. But before that, we are going to look at the advantages of friend functions. So the declaration can be anywhere in the code. It is not passed to the derived class, right? So one advantage is that the declaration can be there anywhere in the code, and it is not passed to the derived class, right? So it is basically a global function, right? So you create it inside a class, but it will be accessible for you globally, right? So you will be able to access it globally, right? So it is not passed to the derived class. It's not a member of the class in which it is defined, like over here, right? And it won't be a member of the derived class also. It will be a global function like any other function that you have. So declaration can be there anywhere in the code. We know that there is no need to create an object to call it, right? So you can directly use find max without creating an object to call find max, right? One of the advantages is that also. So non-public members of the class can also be accessed using the friend function. So non-public members like private, protected can also be accessed using the friend function. So it also works like your getters and setters that we learned about in a basic course also. And getters and setters allow you give you the functionality to access your private and protected members and change your private and protected members, right? So we are going to look at getters and setters again in this course also, right? But we have already learned about it in the basic course also, right? It can add extra functionality. So it adds extra functionality in your program, and it enables programming experience to be more efficient than ever before, right? So it makes your programming experience very efficient. Now let's look at an example. We have a class largest over here, right, in which we have three variables of integer type a, b, and m, right? Then publicly we are creating set data, and we didn't have to create this publicly. We could have created this friend function anywhere in this class. right? So now this friend function has access to any private or protected member of this class. Also, it already has access to these members like ABM. It also has access to private and protected members of this class. We don't have any private and protected members of this class, but if we had any private or protected members in this class, then we would have had access to them from this find max method. And over here we are just giving the declaration of these functions. We are giving the declaration of set data, and we are setting the return type to void, meaning that it won't return anything. And then we are giving the declaration of find max. We are telling it's a friend function. It will take an object of this class itself. So any object of the largest class can be passed to the find max function, and it will further use it, and we are going to see how it is gonna use it in its definition, right? And basically we have its return type void, so it won't return anything. Now we are giving definitions to both the function set data and find max. So when giving the definition to set data method, we are using the scope resolution operator. First of all, that's how we saw to how to give definitions to the functions that we create inside the class using the scope resolution operator, right? We have to specify the return type that we gave over here, right? And in set data, what we are doing, we are printing enter the first number, taking the input and saving it in A, right? And then A is our variable that we created over here in largest, right? And then we are saying enter the second number, and we are saving it in B, right? So great. So whenever on whichever object this set data method will be called, then whatever input will be given, that input will be set as A and B for that object, right? Next we have the find max method, and note we don't have to use the scope resolution operator over here to give it the definition. We directly give it the definition. Why is that? Because this is not a member of this class largest. If we have to use the scope resolution operator for the members of this class largest, we don't have to use the scope resolution operator for functions that are not members of this class. So find max is not a member of this largest class, so we are directly giving find max its definition like we can give to any other function, right? And it will automatically detect that this definition is for the function that we have declared over here, right? And we have to specify the return type, and we don't have to give the friend keyword over here in the start. That only needs to go in the declaration, right? And we are taking in the object of the largest class T, right? And if T dot A, so the A value of of the object passed is greater than T dot B, then T dot M's value, that is over here, will be set to T dot A, else T dot M's value will be set to T dot B, right? And a maximum number is, and then we are giving a tab, right, using the \T character, right, escape character. So we are giving a tab, right, and we are saying T dot M. So whichever value first, what we'll do, we'll take in the inputs from the user, right? Then what we are going to do when find max will be called, we are going to check on the object, if its A value is greater than the B value in it, then you're setting the M value to be A, right? Else if its if its B value is greater than its A value, then we are setting its M value to B value, right? And we are then in the end saying maximum number is, and we are saying T dot M, right? And in the main method, what we have largest and we are creating an object of the largest class L, right? Then we are doing set data, right? So whatever inputs will be entered to the user, the first input will be set as a value of A for this object, and the second input will be set as the value B of this object. Then when we do find max, right, and we pass it L, right? So find max will get L. It will say L dot A, right? So it will check L dot A if the user entered the first number if the first number entered by the user is greater than the second number entered by the user, then the maximum values maximum T dot M's value will be set to T dot A, else it will be set to T dot B. So if I set the first number, when we call set data, if I say the first number, enter the first number, and I say 5, enter the second number, I say 2, right? And then we are doing find max. Note, we are not calling it on the object, as this is for us, right? So we can use it normally like any other function, right? And what we are doing, it is just checking if 5 is greater than 2, right? So that is true, so it will set T dot M's value to T dot A, right? And then so basically when it checks when it prints T dot M's value, we'll get 5, right? So right now over here there's no option of entering the input over here, right? So if we check, there's no option of entering the input over here, right? So that's why we are getting it like this. But if we try this on another editor, this will work perfectly fine, right? So I hope this example is clear.
That's clear.
Great. So now we have seen basics of functions, friend function, we had seen function with default arguments, type conversion, causes of function overloading, right? We saw the errors that we get most often. And yeah, so yesterday what was happening, I was directly trying to call the add function on the cal class, right? Right, so this wasn't working, so we were getting an error, but this was a static method, so it should have worked. So the mistake over here was that we used the scope resolution operator when we have to do this thing, right? So when we have to call it on the class name itself, we'll have to use the scope resolution operator and not the dot operator, and now it is working perfectly fine. So I hope the confusion that was there in the previous class is clear now.
Yeah, got it.
Great. So now we are going to look at the interesting facts about bitwise operators once again, right? As we are going to use these bitwise operators in the further chapter, right? So we are going to go through these very quickly, right? So the left shift and right shift operators should not be used for negative numbers. We saw this, that if the second operand which decides the number of shifts, right? So we can shift by 1, we can shift by 2, we can shift by 3, but if the second operand is a negative number, it results in undefined behavior in C++. So if you are given negative number, it will be an undefined behavior, right? So one left shift -1 and one right shift -1 is leading to undefined behavior. So also so we should never shift it. The second operand that we give after the left shift or right shift operator should never be negative. Also, if the number is shifted more than the size of the integer, the behavior is undefined. So for example, if we say 1 shift 33, right? So if you try to shift it 33 bits, right? But integer is 4 bytes, that is 32 bits, right? But if you try to shift it by 33 bits, right? So it will exceed the size of the integer, and this is undefined, right? So if you try to shift more than the size of an integer, the behavior is undefined, right? So so for example, one left shift 33 times is undefined if integers are stored using 32 bits. Another thing is, no shift operation is formed if the additive expression operand that decides number of shift is 0. So if we shift 0 times, basically what this is saying, if we shift 0 times, so over here if we shift 1 left shift 0 or 1 right shift 0, right? So if we give the right or the second operand to be 0, right, then no shift operation will be carried out, right? And whatever number you gave over here will remain the same, right? So if we say 1 left shift by 0, so it will give us 1 once again. If we say 2 left shift 0, if we say 100 left shift 0, it will give us the number itself, as shifting it by 0 or left shifting it by 0 or right shifting it by 0 will give the number itself. right? So this was the left shift and right shift operators. Next we have the second point. Interestingly, the bitwise OR of two numbers is just the sum of those two numbers if there is no carry involved. Otherwise you just add their bitwise AND. So let's say we have a equals to 5, that is 101, and we have b equals to 2, that is 010. Since there is no carry involved, so over here let's just open this editor, right? So no carry involved means over here like 10, if I say like if we have some big number 592, this is normal decimal, right? And we have 210, right? So carry involved over here, what it's referring to as, so let's just do normal addition. So 2, right? So then 9 plus 1 10, right? So over here we'll get 0 and 1 will be carried forward, right? So this is what it is referring to as carry involved, right? So over here last time this was the confusion about what it was referring to as carry involved. So if there is no carry involved, now what we have when we are we have a equals to 5 101 and b equals to 2 010. So since there is no carry involved, so when there is no carry involved, let's see what do we mean by carry involved. When we say 101 and we add 010, right? So there is no carry involved. So let's just take another example like 110, so where there is a carry involved, right? So over here we have 1 and 0 will give us 1, right, when adding, right? And 1 and 0 will give us 1 only, right? And over here 1 and 1 will give us 2, right? So 1 and 1 is giving us 2, so that is carry involved in bitwise. So this will over here come 0 and in the start we'll get 1. So this number will be formed 1011. So over here a carry was involved. When 1 and 1 were added, we got 2, right? And 0 came over here and 1 was carried forward, right? So over here when doing 101 and 010, let's try that. When we say 101 and 010, then there is no carry involved. Look, so we have 101, right? Then we have 011 and then we have 101, right? So there was no carry involved, right? So when there is no carry involved, the sum is just a or b. So the sum will be just a or b. So now if we change a to 6, right? So if we change a to 6, that is 110. So when we say 110 plus 010, so when we say 110 plus 010, right, the sum would change to a or b plus a and b, since there is a carry involved. So now there will be a carry involved, right? So let's see. So we get we have a carry involved, so we have 0 over here. Then 1 and 1 will give us 0 and 1 will be carried forward, right? And then also we'll have 1 and 1, so this will also give 0 and 1 will be carried forward. So in the end we'll get this number, right? So what we will have this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So 1 into 2 raised to power 3, 2 raised to power 3 is 8, and 6 plus 2 is also 8, right? So we are getting this correct number. But to do now this was normal addition. If we have to do on the bit level, if we have to do addition, if there is no carry involved, we can just directly do a or b, right? And if there is a carry involved, then we can say a or b plus a and b, right? And if there is no carry involved, then also this formula will work fine, a or b and a plus a and b, right? Why? Let's just check. When we have 101, it's 101 and 010, 101 and 010, then let's just do the OR first, right? So that is their sum, right? So 1 and 0 will give 1, right? 0 and 1 will give 1, and 1 and 0 will give 1, right? So 1 or 0, 0 or 1, and 1 or 0. So 1 is 1 into 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So 2 raised to power 0 is 1, 1 plus 2 raised to power 1, that is 2, and 2 raised to power 4. So we have 4 plus 2 plus 1. So 4 plus 2 plus 1 is 7, and 5 plus 2 is also 7. So we are getting the sum. Now if we would have done a, this was a or b, if we would have used the formula a or b plus a and b, then also it would have worked fine. So A or B is giving us 1 and 1, 1 1 1, and look, when we do A and B, then what happens? 1 and 0, this will give us 0, right? 0 and 1, this will give us 0. 1 and 0, this will give us 0. So in the end we are just adding 0, so in the end we are still left with 1 and 1 1 1, and that is 7, right? So this formula will work for both when there's a carry involved and if there's no carry involved, right? And A or B will basically give you the sum when there's no carry involved. A or B plus A and B will give you the sum in both the cases when there's no carry involved and when there is a carry involved. All right, great. So next, what we have next point is the bitwise XOR operator is the most useful operator from a technical interview perspective. So basically what happens in XOR, so if you have basically if over here in this example we were taking out the number that was repeating odd number of times. So what happens when you have the same number, exact number? So for example if you want to check out if two numbers are same, then one way to do it, let me show you one way to do if two numbers are same, if A equals to B, right? So one way to do it, like A equals to B, then same else not same, right? So one way to check if two numbers are same is this. Another way to check if two numbers are same is using the XOR operator. We can say A XOR B, right? If this is not same and this is same. Now why? A or XOR B will give you 0 when both the numbers are same. So A, for example, is 12, B is, for example, 12. Both binary representation is the same, and we know in XOR when we have like bits, then it gives 0. When we have unlike bits, it gives 1. Now if the full number is the same, right? If the full let's just take the example of 1 or 2, right? So 2 was 0 1 0, right? And A is 0 1 0, B is 0 1 0. Now if the full number is same, then 0 0 will give us 0, 1 1 will give us 0, 0 0 will give us 0, as 0 0 is like bits, 1 1 are like bits, and 0 0 are like bits. So the whole thing will give us 0, right? So when the two numbers are same, the XOR when you doing the XOR operation, this whole thing will be 0 when A and B are the same, right? But when they are not same, for example, we have over here we have 101 and 010. So if we have 101 and we have 010, so these are not same, and when we are doing XOR, all of these are unlike bits, so in the end we'll get 111, and this has a certain value. This is 7, right? So when we are getting a value over here, a non-zero value, then the numbers are not same. But when the XOR operator gives us a 0 value, then basically then the numbers are same, right? So using this concept only, this example was made over here, right? Where what is happening, we have this main function in which we have an array. We have 12 12 14 90 14 14 14. So what is happening, if this 12 and this 12 are cancelling each other, this 14 and this 14 were cancelling each other, and this 14 and this 14 were cancelling each other, and 90 was not getting cancelled, right? So that's why 90 was left in our result, right? And we were getting the odd occurring element was 90, right? So we have array 12 12 14 90 90 14 14 14, right? And then we have n, right? So what is the size of array? It is a size of array divided by size of array 0, as size of array will give us how much memory this array occupies, and we have to divide it by size of array 0 to tell what is the length of this array, right? Then we are calling find odd and passing it array and n, right? So in this we have we have an integer. We have creating two integer variables. One is result, whose default value is 0, and then we have I, right? So we are creating two integer variables, result and I, right? So then we are looping for I equals to 0, I less than n. So we are looping on this array, and what we are saying result xor equals to array I. So now we are doing 0 xor equals to array I, right? So 0 xor equals to this will give us 12, right? So 12 xor equals to 0 will give us 12 in result, right? Next 12 will come once again. So 12 xor equals to 12 will give us 0, right? Because all the bits will be like bits, so the result will be reset to 0. Then we have 14. So 0 xor equals to 14, that will give us 14, as when there will be like bits also, when there will be 0 and 0, we will get 0 only, right? So now when in result we have 14, right? Then when we say 14 xor equals to 90, right? So then what will happen, we'll have a number like 84, right? So we saw that we were getting a number like 84, right? So then further, when we do xy equals to 14, right? So let's just calculate this also, right? So let's just say 14 bit by binary representation, right? So sorry about that, 14 binary representation. So we get 1110. So we have 1110, and then we have 90 binary representation, right? So it is 1011010. It's 1011010, right? And in the start we have zeros, right? So when we do at the XOR of this, let's see, 0 and 1 1, 0 0 0, 0 1 1, 1 1 0, 0 1 1 1 1 0, 0 0 0. So we get 1 0 1 0 1 0 0, right? So we get this number as the result. Now if we say this to decimal, right? So if we check this, we get 84, right? So now we have 84 in our result, right? And now we are doing this XOR with 14 once again, right? So now we have 84. Now we are doing this with 14 once again, right? So 14 was again 0 0 0 0 1 1 1 0, right? So let's just delete this part, right? So now we are doing 84 XOR 14, right? So what we have 101 0 0 0 101 011 110 011 000, right? And when we check this, we again, what we get 90, right? So we get 90, right? And then when we do it XOR with 14, this 14, right, then we'll get 84, and then we further do XOR with 14, we'll get 90. So in result we will get 90, right? And then the result 90 will get returned, and that will be printed. All right, great. So is this example clear, all the three examples? Hello?
I'm sorry, my mic got some issue. It's clear.
All right, great. So great. So now we saw this this was also pretty clear to us, that the result of the logical operators and, or double or and not is either 0 or 1, but bitwise operators return an integer value, right? So bitwise operators are used to perform some operation, and this logical operator double or not are used to basically give us true or false, like to compare values, right? So also the logical operators consider any non-zero operand as 1, right? So they consider any non-zero operand as 1. For example, consider the following program: the results and are different for the same operand. So basically they are telling that we should not use single and, that is a bitwise operator, in place of the logical operator double and. So we have x equals to 2, y equals to 5, right? And when we say x single and y, then what we are doing, we are saying we are performing a binary operation and, right? And what will happen, basically 2 is 0 1 0 and 5 is 1 0 1, right? And when we do its and, we'll get 0 over here, and 0 will go over here and print false. And then when we use double and, so 2 and 5, it will check if both the values are truthy. So both the values are truthy, so it will go over here and print true. So first false will be printed and then true will be printed. So we are getting completely different results over here. That's why they are just telling that we should not use the bitwise operator in place of the logical operator. So wherever the logical operator is used, we should not use the bitwise operator. Now the left shift and right shift operators are equivalent to multiplication and division by 2 respectively. So they are like basically equivalent to multiplication and division by 2. So when we do left shift, it's multiplication by 2. So 19 left, we are left shifting it left by 1. So 19 into 2, we are getting 38. When we right shift it by 1, right, and then what we get, 19 divided by 2. Now 19 divided by 2, it will be floor division, it will be 9.5, right? So 9.5, it's floor division, so it will give us 9, right? So right shift is equivalent to floor division, left shift is equivalent to multiplication by 2. So the AND operator can be used quickly to check if a number is odd or even. Now, if a number is odd, then it's the first bit, right? So the rightmost bit will always be 1, right? So if your number is odd, then the rightmost bit will always be 1. Why? Because that is the only bit that gives you an odd number, as 2 raised to power 0 is 1, and that will only lead you to an odd number. Every bit will give you even. So 2 raised to power 1 is even, 2 raised to power 2 is even, 2 raised to power 3 is even. So every bit will give you even. Only the rightmost bit, that is 2 raised to power 0, will lead you to a odd number. So if your rightmost bit is if your rightmost bit is 1, then your whole number is odd. And if your rightmost bit is 0, then your whole number is even, right? So when we do x and 1, when we do directly by 1, what we have 0 0 0 1. 0 0 0 1 is a formula of your basically your your in decimal 1. So when we do x and 1, what will happen, let's check. So let's just take out the 19 binary representation, binary. So it's 1 0 0 1 1. So 19 is an odd number, right? So 19 we have 1 0 0 1 1, right? So it's 1 0 0 1 1, right? And in the start, this is 5 bits, 6 7 8. All right? And then 1 is 0 0 0 0 0 0 0 and then 1, right? So now when we do its and, what will we get? Alright, so what will we get? Let's just start from here. 0 0 will give us 0, 0 0 will give us 0, 0 0 will give us 0, 1 0 will give us 0, 0 0 will give us 0, 0 0 will give us 0, 1 0 will give us 0, 1 1 will give us 1, right? So what we are getting the number 1, and 1 is a truthy value, right? So if it is a truthy value, when this gives you a truthy value, it will go here, and then it means if x and 1 gives you 1, right, that means it's an odd number. Else if it was even, right, so let's just say it was even, right? So what would have been the formula of 19? It would have been this. So let's just do this once again. 0 0 will give us 0, 0 0 will give us 0, 0 0 will give us 0, 1 0 will give us 0, 0 0 will give us 0, 0 0 will give us 0, 1 0 will give us 0, 0 1 will give us 0. So now the whole number over here that we are getting is 0. So what will happen? It will not go over here. It is a falsy value, so it will go over here and it will print even, right? So if we just run this, we'll get even. Now the tilde operator should be used very carefully. right? So this tilde operator should be used very carefully. So result of the tilde operator on a small number can be a big number if the result is stored in an unsigned variable. So when you have an alright, I'll just explain this when we reach to the example. And the result may be a negative number if the result is stored in a signed variable, assuming the negative numbers are stored in 2's complement form. The leftmost bit is the signed bit. So when you create a signed number and an unsigned number, when you have an unsigned number, meaning when you have only positive numbers, then what does the tilde do? It reverses all the bits. So if you have saved 1 in this, so there are 0 in the start, and in the end you have 1, right? So when this is unsigned and you will use tilde on this, then what will happen? First you had 32 zeros in the start, 4, 8, right? 8, then 16, 24, 32, right? And you will have 31 zeros, and then the 32nd bit will be 1, right? So this is the binary representation of 1, right? So now when you use tilde on this, all of these will be converted to 1, and this last bit will be converted to 0. 1 1 1 1 1 1 1 1, and then when we copy this, command C, 1 4 and right. So this will be your new number, right? And as this is an unsigned number, right, this is an unsigned number, this will be a very very big number. This is not a signed bit, right, that will change the sign. This is an unsigned number, so this will be a very very big number. So if we convert this to decimal, right, so when we convert this to decimal, we get 42949679294, right? And what this is what we are getting, 42949679294. And when we have a signed number, then the sign of the number will change. From positive it will be negative, right? So 1 will not be such a big number when it's a signed number, right? Its sign will change, right? And when we'll use tilde on this, we'll get negative 2 on 2's complement, right? So we should never use we should avoid using the tilde operator on unsigned numbers as it will give us a very very big number. Alright, so now that we have done bitwise operators, I just want to confirm if the bitwise operators are clear.
Yeah, it's clear.
Alright, great. So now we are on the sizeof operator, and we have seen the sizeof operator pretty much all of the things, right? The some of the things that I needed to brush up on were nesting of sizeof operator, finding the size of the structure, and finding the size of the union. Alright, so nesting the size of the operator, over here, when we are nesting the size of operator, what this size of operator value, when we use size of operator, the number it returns, that is stored in 8 bytes, right? That number that is returned is stored in 8 bytes. So when we say size of y, right, so this is an 8 byte number. This number that we'll get will be saved in 8 bytes, right? And when we multiply a number that is saved in 8 bytes and a number that is saved in 4 bytes, then the resulting number will be saved in 8 bytes. And when we take out the size of that 8 byte number, we will get 8, right, as it is occupying 8 bytes. So right now what is happening, size of y will give us 8, right? And this number that is returned is saved in 8 bytes in the memory, right? It's occupying 8 bytes of the memory, right? And then when we are multiplying x with it, right, so x value, whatever it is, when we are multiplying it with this number, that and we pass it to sizeof, then because this is saved in 8 bytes and this is saved in 4 bytes, right? So the result will be the bigger byte, the resulting number will be saved in the bigger size, right? So 8 bytes is bigger than 4 bytes, right? So that's why the resulting number of this multiplication will be saved in 8 bytes, and when we take out the size of that, we get 8. Alright, then when we find the size of the structure, it's basically the size of all of these, right? So int z, right, so int z, it is 4 bytes, float is 4 bytes, and then we have a char array that is containing 20 char elements, so that is 20 bytes. So 20 plus 4 plus 4, 28, so this will give us 28 bytes. And finally, in union, a union is a data type that will occupy the whatever variable or element in it has a greater size, that will be the size of the union. So double has 8 byte size, so basically the union size will also be 8 bytes. So when we check the size of the union, it will be 8. If we said long double, that is 16 bytes, so the union size when we check will also be 16. Alright, so now we are going to continue in the next class with the return statement in C++.